Hello everybody and welcome back to another video. In this video, I'll be covering this series, 1 plus 1/2 plus 1/3 plus 1/4 plus all the way up to 1 over infinity. So we are calculating the inverse of all of these integers. And we are adding them up and we are testing if they converge or if they diverge. So convergence or divergence essentially means if something will be enclosed within a value. So for example, if you look at the integral from 1 to infinity of 1 over x squared dx, so this goes to the integral of as b approaches infinity. There's a limit as b approaches infinity of b to 1 of x to the negative 2 dx. So this goes to x to the negative 1 times negative 1, so evaluated from 1 to b, and then this is the limit as b approaches infinity. So this is negative 1 over b plus 1 over 1, and then the limit as b approaches infinity. So this is just going to go to 0, so that goes away, this goes away, and this is equal to 1. So we would say that this integral converges. However, if we had something like the integral of x from 1 to infinity, the x, you would be able to tell that this is just x squared over 2, evaluated from 1 to infinity. Infinity squared, that's just going to be infinity. That's going to diverge. You can't encase that in a value. So this would diverge. So what we are trying to find out is if this series converges or diverges. Now to begin, let's look at the graph of 1 divided by x. So we have x right here, then we have f of x, and this is f of x is equal to 1 divided by x. Now let's look at a left-hand Riemann sum of 1 over x, and we will do it from 1 to infinity. So we are going to be starting at 1, and we will be going all the way to infinity. So this right here, and we will be using a step size of 1. So delta x is 1. So this is just f of 1 times 1. So this is f1 times 1 plus, then this would be f of 2 times 1. And as you can probably see already, this is f of 3. So this is just plus f of 3 plus all the way up to f of infinity times 1. So it's just all times 1. And now let's look at this with this function of 1 over x. So this is 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3 plus dot 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 plus 1 divided by infinity. So this is the sum, starting at 1, of 1 divided by x, and that is awfully similar to what we're trying to find. If you replace x and n, then you will see that these are equal. So we'll say that n implies x, or n is equal to x, so these are just interchangeable variables. So let's see what we can do to this graph. So this is 1 over x, right? And as you can see, this area, these areas right here, are equal to our sum. And if you look closer, I'll draw it again right here. I'll do less labeling this time for time's sake. So since this is like this, this, all the way up forever, as you can see, these areas are actually over approximations of this area. So essentially, this area that I'm shading in right now is the integral. So this integral of 1 over x from 1 to infinity with respect to x. And this is the sum. All these are the sum. So what this means is that the sum of 1 divided by x going to infinity starting from 1 is greater than the integral from 1 to infinity of 1 divided by x with respect to x. So now let's see this integral of 1 over x. So we are going to rewrite this as the limit as b approaches infinity of the integral of from 1 to b of 1 over x dx, and this is just the logarithm, natural log of b minus the natural log of 1, which is just 0, so this is minus 0, so this just goes away. And this is the limit as b approaches infinity. So we'll write this right here. So limit as of ln of b as b approaches infinity is going to be less than our sum that we are trying to find. So I'm going to replace n and x right now. So this is n is equal to 1, 1 divided by n. So now, this is just infinity. You could plug in any number, since this is the inverse of e to the x, and you could plug in any number, you could plug in something approaching infinity to e to the x. That means that the limit as b approaches infinity of the ln of the absolute value of b is just going to be infinity, essentially. So this is saying that infinity is less than our sum right here, from infinity starting at 1 of 1 divided by n. So it's not actually going to be more than infinity. You can't be more than infinity, really. There are different types of infinities. However, this is still a countable infinity. So we know that this series just diverges. So this is just for sake of the proof. However, now we can state that this series diverges by the integral test. So, there's our answer. We found out that this series diverges. Now, it does not seem like it would to some people. However, the math is always right as long as you're doing it right. So, anyway, I hope you all enjoyed this video. Please like and subscribe, and thanks for watching.